Yeah, thank you. So let us start session. So last session. Yeah. So last session, just basic started. Java basic started. Yes, the basics, software basics. Last session explained about software basics. Yes, so last session, yes, introduction to software, about system software, yes, application software. Next about OS, expense, and then front end, back end, these things discussed. Java is a backend software, and its language. Java is language. In languages, low level, high level languages. See generation of computers. That five generations discussed. Next, AI about AI also some topic expanded. Okay. Yes, if AI comes, what happens in future? That also very clearly expanded. Even AI comes, no threat in jobs. That already discussed. Explained clearly yesterday. Yes. So low level language, high level language. Low level language is a machine language, like zeros ones format. High level language, it's a user understandable language, right? High level language is a user understandable language. Yes, high level language like C, C++, Java, all they are high level languages. All these are high level languages, right? Every high level language program has to convert into binary code. See, these are in English. Java program like English language, Python is like English language, HTML like English language, C and C++ like English language. So all are looks like English language. Now these languages have to convert into binary code, that high level languages. Okay. So high level language to binary code. So for this, yes, interpreter or compiler converts from high level language to binary code. Let us see about this. Interpreter, compiler. Yes, today topic is about interpreter versus compiler. Yes, interesting topic. Yeah. So topic interpreter versus compiler. Yes, very interesting topic. Yes, interpreter versus compiler. Interpreter versus compiler. The differences. See, interpreter and compiler both are to convert. Interpreter and compiler both are to convert from high level language to binary code. See, both are to convert it. Okay. Yes, both are to. So both are to convert from high level language to binary code. Both are to convert from high level language to binary code. But some difference is there. But some difference. What's the difference? So first let us see about interpreter. Interpreter. Let us see. First interpreter about interpreter. For interpreter, I'm taking Python. Python is the best example. So Python is a best example for the interpreter based language. For example, yes, test.py, some Python script. Okay. Yes, let me write some Python script here, very simple scripts. D try. Okay. Suppose new folder. Suppose some sample folder. Yes, here I'm writing simple Python script using Notepad. Just I'm writing Python script using Notepad. So D drive. So D drive sample. So here using Notepad, just a simple Python script I'm writing here. Yes, using command prompt. First you go to command prompt. Yeah, this is command prompt. or we can say command line interface, CLI, command line interface, command prompt, right? From this, we should go to D drive and then sample, right? D drive, next sample for D drive, D colon will take to D drive, D colon will take to D drive, CLS to clear the screen, screen cleared. Okay, not DER, directory contents, D drive contents. See, all these are D drive contents, right? All these are D drive contents. So DER means what? Directory. DER means is directory. All the directories here. All the directories here. What is directory? See, D drive. See, there are folders, right? All the folders like Dsoft, see MNRA frameworks, MNRA Hadoop, MNRA Java. So all the names starting with MNRA is a folder, right? So these are our folders. These are our folders here. Same names here directory. So directory folder both are same. Directory folder both are same, no difference here. In character interface, calling as directory. In character interface, it's a character interface. So here calling as directory. Yes, GUI, Windows GUI, graphical interface. Graphical is an interface. Here calling as folder. So folder, directory both are same. Yes, in graphical interface, folder. In character interface, directory. Okay, fine. Now, yes, from D drive, we should go to sample folder. D drive sample, right? D drive sample. Now here, see, dir sample directory. So this is sample directory, sample directory. Yes, CD. CD means change of directory. CD change of directory. CD sample, right? CD change of directory. Yes, directory changed. CLS, clear the screen. See, present working location sample. Sample. dir, checking contents, right? So that sample directory contents here. Sample directory contents. See, that's 0 files. Nothing is there. Just it's 0 files. Sample directory, 0 files. See, this folder is empty. This folder is empty. Yes, now let us write simple Python script. Yes, notepad. Yes, notepad. Yes, test.py. See, our topic is about interpreter, not about Python. Okay, I'm explaining about interpreter. Okay, so in the process of explanation, just I'm using Python example. Python example. Okay, so notepad test.py. Yes. Do you want to create new file? Yes. Now Python script, very simple script. A is equal to 10. Yes, B is equal to 20. Okay, C equal to yes, A plus B. Addition. Yes, print. So print displaying that output here. Print. Yes, addition. Yes, addition. Yes, addition is equal to C value, displaying C value. Next, C equal to A minus B, right? C equal to A minus B. Yes, print. Print. Yes, subtraction. Subtraction is equal to displaying C value, right? Yes, C equal to A into B. C equal to A into B, right? Yes, print. So print. Yes, next multiplication. Yes, very simple program. So multiplication. So multiplication is equal to C, right? Yes. It's a very simple script here. So here, yes, adding two numbers, subtracting two numbers, and a multiplication of two numbers. So this is a simple script, very simple script. Save, Control S, notepad, Control S, save and close. Yes, back to command prompt. Command prompt, yes, dir series. Test.py, right? Okay, that file created. So that file, right? Just now created today, right? Now run it. Python, yes, test.py series. Addition, subtraction, multiplication, right? Done. Successfully completed. Addition, subtraction, multiplication. Yes. How this is working here? Okay. So directly program executed. Suppose any errors, what happens here? Suppose any error comes, what happens? So any error. Suppose there are some mistakes. Suppose here bracket missing, for example, bracket missing. Okay. Suppose here, for example, here double quotation missing. Okay, right? Suppose here this bracket missing. Then what happens here? Yes, how it's working? Yeah, there are three errors. So here first mistake, next mistake, next. It's totally three errors. Now what happens here? Save. Back to this. Yes. CLS, DER. Yes. Now executing program. right? See, here this error, right? Syntax, line number 8, addition. But actually there are 3 errors, but showing only 1 error. Yes, totally in this script there are 3 errors. There are 3 errors, but showing only 1 error. So then how this interpreter is working? So how that interpreter is working? Let me explain that interpreter working here. How that interpreter is working. Okay, so these are the coding statements, right? Yes. Yes, script statements. How it's working. Let me explain clearly. Yes, how that interpreter, any interpreter working same. Maybe Python interpreter. So PHP interpreter or shell scripting interpreter. Okay, maybe Perl scripting interpreter. Okay, so any script JavaScript interpreter, HTML interpreter, like that, there are different language, interpreter-based language. Same working. Yes, let us see. Let me explain clearly here. So first, yes, checking line by line. Interpreter checks the code line by line, checking first line. Yes, if it is correct. If it is correct, then checking next line. Next line checking. Next line also correct. Then checking next line. Suppose next line also correct. Then checking next line, this line, right? Here something wrong. Yes, if any something wrong here, simply stops. Here only stops. Just stops here. It won't check for yes, rest of the program. Okay. See interpreter. Yes, checking code line by line. First line, next line, next line. If any error comes, simply stops. Okay, suppose here something wrong here. 1 second. So this statement wrong, right? Okay. So first line checking correct. Next line checking correct. Next line checking correct. Next line this is something wrong. Simply stops. So any error comes, simply stops. So this is working of interpreter. Okay. So Python checks the interpreter. Interpreter checks the code line by line. Interpreter checks the code line by line. If any error comes, simply stops. So interpreter checks the code line by line. If any error comes, simply stops. It won't check for rest of the code. Any error comes, simply stops. Any error comes, simply stops. Okay, right? Yes. See that. Only this error, right? That 8th line error. So this is showing only 1 error, not showing all the errors. So this one showing only 1 error, not showing all the errors. Now let us correct that mistake here. So this error, right? This mistake. Yes, correction is done. Save, and run it here. Yes, CLS, save, run it. 1 second. Save and run it. See, I'm using up arrow key to get the previous commands. Up arrow key. So command prompt will maintain the history. See that up arrow key, the previous all the threads. Okay, that history. Okay, up arrow. Yes, CLS. Yes, see that. Now here 12th line error, right? Now here it's giving 12th line error. So that 8th line error corrected. Now 12th line error. So this is showing only 1 error here. Any error comes, simply stops. Any error, simply stops. Any error, simply stops. Not 12th line. So this W quotation missing, right? W quotation missing. Yes, correction is done. After correction, save it. Save it. Control S. Saved. After saving, now let us run once again here. Yes, now 16th line error. Now it's giving 16th line error. So this is showing only 1 error. Right? Interpreter showing only 1 error. So 16th line. So here closing bracket, right? Save it. Save it. Yes. Next, run it here. Yes. Run it. Yes, that's all. That's it. Okay. Right? Yes. The program, that code executing directly, or source code executing directly here. Okay. Yes. So what is happening here? So here interpreter checks the line by line. If any error comes, it stops. So interpreter shows only 1 error. Interpreter shows only 1 error. Suppose everything is fine, top to bottom, then what happens here? Suppose everything is fine, next line also correct. Suppose next line also correct. So next statement. Suppose all these statements correct, then what happens? How it's working here? So what is next step? Okay, so everything is correct. If everything is correct, then what is next step here? Then that interpreter taking first line, simply interpreter. So all are correct. After that, now starts execution. So first line converting into binary codes like zeros ones formats, right? So this binary format given to processor. Okay, given to processor, right? That processor simply generates output. Okay, so first line converting into binary format, that binary format given to processor. So processor executes generating output, right? So next line, second line. Now second line starts. Second line, yes, converting into binary format. That binary format given to processor. Simply that will be given to processor, right? So processor taking and generating output simply, right? Like this next line also, like this next line also converting. So next line, the zeros ones format, then binary format. Okay, yes, next line given to processor, right? Processor. Okay, that code generates output, right? So what is happening here? So line by line, yes, converting and executing, converting, executing, converting, executing. But this result code not storing anywhere. Okay, interpreter converts the code into binary format, then executes. Converts the code, then executes. Converts code, then executes. But this binary format, this binary code will not store anywhere. This is working of interpreter. So working of interpreter is like this, right? Now let us see compiler. So compiler. So for compiler, best example is C language. Yes, compiler. 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 Yes, I am taking C program. For this C program, suppose some test dots C program, right? How that C program is working here? Let me show the C program also. Yes, C program. File, open. Yes, that's C program. Yes, you guys, can you see my screen now? The C program. Hello.
Yes, sir.
Yes,
Yeah,
sir, we
that
can.
ID changed. The blue screen, you can see blue screen, right?
Yeah, blue screen.
Blue
Yes.
screen, right? Okay, fine. Yes, see, int A, int B, int C. Yes. So you enter first number, reading first number, enter second number, reading second number, C equal to A plus B, same program. Addition, next subtraction, next multiplication. Right? Same program, but it's C program. Yes, now compile. Compile success, no error. Run it. Yes. First number 10, second number 20. Right? Addition 30, subtraction minus 10, multiplication 200. That's it. Successfully completed. Suppose any error comes, what happens here? Any error. For example, here semicolon missing. Okay. Suppose here, for example, this double quotation missing. Double quotation missing. Suppose here, for example, yes, semicolon missing. Okay. Suppose here some bracket missing. So by mistakes. So by mistake, suppose here, let us semicolon missing. Okay. Yes, suppose here comma missing. Comma missing. Right here, suppose some bracket missing. Yes, save. So once program modified, you have to save it. No compilation. Just I'm compiling program. Compiled. So errors, right? Totally 8 errors. Here showing 8 errors. Showing 8 errors. Totally showing 8 errors. There are 8 errors, right? Yes, press any key. See. Errors. Look at the pattern. 7th line error, 11th line error, 17th line error, next 19th line, 25th line, 27th line, 29th line, right? So compiler checks the whole code from top to bottom, shows all the errors. Okay. Yes, see 7th line error. Even 7th line error comes, it goes to 11th line. It goes next line, next line. So top to bottom. Compiler checks the whole code from top to bottom. Compiler checks whole code from top to bottom. Compiler checks whole code from top to bottom. 1 second. See how that compile is working. Let me explain. Compile working. Right? Yeah. Suppose C program. Just Just imagine like a C program. First statement, C program. So next statement, C program. Next statement. So there are some statements like this. In C program, there are some statements. Just imagine like a C program, this code. Yes, how compile is working here. Yes, how compile is working. Yes, how compile is working here. How compile is working. Let me explain clearly how compile is working. See, compiler checks the first statement. If first statement correct, then checking next statement. Next, checking next step. Suppose something wrong here. Here then compiler shows error at line 3. After that, checking next line. If it is correct, checking next line. If it is correct, next line. Suppose any error at some line, right? So checking next line, checking next line. So checking next line. So compiler checks the whole code from top to bottom and shows all the errors. See, in case of interpreter, what happens here? Any error comes, stops. Interpreter, any error comes, simply stops. But compiler is not like that. Even error comes, it goes next statement, next statement, next statement. So next error, next error. So compiler checks the whole code from top to bottom and shows all the errors. Compiler shows all the errors. See that compiler is all the errors, right? Compiler all the errors. Let us correct these errors here. Suppose here bracket missing. Let me correct all these errors here. So here semicolon missing. Okay, suppose here, yes, double quotation missing. Yes, save it. After modification, say yes, overwrite, yes. Again, recompiling. Still some more errors. Still 4 errors, right? 4 errors. Let us correct the mistakes here. So next errors. So here, so the semicolon missing, and then yes, here also semicolon missing. Okay, right? Yes. Next here, some comma missing, right? Now save it. Save. Save overwrite, yes. Now compile. Right? Still one more error. Still one more error. So here this is error, right? Here error. Yes, now save it. Saved. Yes, overwrite, yes. So compile. Yes, success, right? Success. So compile success, right? Yes, if no errors, what happens? Let me explain here. No errors. Yes, everything is fine. If no errors, what happens here? If no errors, okay. So checking that code from top to bottom, everything is fine. If no errors, okay. If no errors, okay. Yes, no errors. Everything is fine. Top to bottom checking. If everything is fine, then what happens here? Top to bottom, if everything is fine, then compiler opens one more file. Compiler opening one more file. So compiler opening one more file. After opening one more file, this code means your C program code, this whole code converts in binary format. These all the lines, whole code converts in binary format, right to another file. Okay, like zeros ones format. So first line converting, then write to another file. Okay, yeah, this file is test.exe. That exe file generates. So test.exe, that exe file creates. Yes, creating one exe file and writing that code, that binary format writing to exe file. So binary format writing to exe file. All that binary format write into exe file, right? Simply binary format writing to exe file. Okay, so compiler whole code converts into binary format, write to another file called as exe file. Yes, see, in case of interpreter, what is happening here? This code executing directly, line by line executing, but this is not storing anywhere. So this binary format not storing anywhere. So binary format not storing anywhere. Okay. Yes. So direct executing. See this. CLS, dir, see test.py, only one file, right? Here don't have exe file. Don't have exe file. So this the Python script direct executing here. Okay, right? Direct executed. There's code, source code executed directly. Source code. Yeah, this is source code executing directly here. Source, this is called a source code. This code executing directly. This code executing directly. So directly running is not creating any exe file. not creating any exe direct, that code executing directly. So when you come to C program, okay, let me show that exe file. When you come to C program, yes. So compile, success, right? Yes, after compilation, yes, generating exe file. Let me show the exe file. See, program successfully completed, right? Yes, behind of this, that exe file generates. Let me show the exe file. C drive, here TC, here Turbo C, here C program, C software installed here, C software, bin folder here files, the test, see test, they are the files. Let me delete that old files. There are some old files. See, so this is your C program, right? Test C program. So this is C program, right? This is C program. Okay. Yes, this is C program. Test. Okay, test.cpp. So CPP means C++. C++ compiler can be used for C language also. CPP compiler for C language also. Now, see, I'll show that exe file. Compile, success. Now here run. So before going to run it, first of all creating one exe file. So when I try to run here exe file generates. Try to run it here, run it. See, observe here, back and see this. This file created, right? This file created. Application means exe. Application means exe. See, check the properties. Properties. See the .exe file created. .exe file created. The .exe file created, right? Okay, now run it. Enter first number 10, next number 20. See, addition, subtraction, multiplication. Okay, I'm repeating once again here. See, I'm deleting this exe file. Test that exe file deleted. Exe file deleted. Okay. Yes, now run it here. Run it. See, observe it. The second exe file created now. Again, 1933, right? 733. Just now created exe file. Yes. Properties. Properties. See the .exe file. That's it. So this is the working of compiler. So compiler generates one exe file. Generating exe file. Simply generating exe file. Okay. So compiler checking whole code from top to bottom. Compiler checking whole code from top to bottom. Yes, if no errors, generating exe file. Now this exe file is submitted to processor. So processor taking that exe file, executes, generates output. That's it. So at a time here, the complete top to bottom, complete codes, yes, exe file. In exe format, yes, submitted to processor, processor taking exe file, generating output. So exe file is a binary code file. Here exe file is a binary code file. Exe file is a binary code file. So this is difference between interpreter and compiler. So this is difference between interpreter and compiler. Let me explain clearly all the differences. Comparison. So comparison of interpreter and compiler. Yes, that comparison. Yes, interpreter and compiler. Let me compare this. Interpreter and compiler. So first difference. Yes, interpreter. It checks the codes line by line, right? Yes. Wait. So I'm missing wait. I'll explain. About Java we'll discuss. Okay, what is Java? We'll discuss wait. Okay, be cool. I'll explain all the topics. Okay. Yes. Yes, interpreter. It checks the codes line by line. Interpreter checks the code line by line. Interpreter checks the code line by line. Right? Compiler. Yes, it checks whole code from top to bottom. It checks whole codes from, yes, top to bottom. From top to bottom. Okay. Yes, interpreter checks the code line by line. Compiler checks the whole code from top to bottom. First point clear, right? Next step. Yes, not only check even execution also. It executes codes line by line. So line by line, converting then executing, converting then executing, converting then executing, right? It executes code line by line. Yes, in case of compiler, what is happening here? That exe file creating, right? So at a time executes. Yes, it executes. Yes, it executes code at a time here. Okay, it executes. Yes, whole code from top to bottom. Whole code. Yes, at a time here. Whole code at a time. Whole code at a time, right? At a time. Okay, right? Yes, next. See, in case of interpreter, yes, if any error comes, stops. If any error comes, it stops. Stops, right? Any error comes, it stops. Interpreter, if any error comes, it stops. Okay, if any error comes, stops. So hence it shows only one error. Hence it shows only one error. It shows only one error. Only one error, right? Yes, when come to compiler. Yes, compiler checks the whole code from top to bottom. So it shows all the errors. Yes, even error comes, it goes next line, next line, next line. Yes, it shows all the errors from top to bottom. It shows, yes, all the errors from top to bottom, from top to bottom, from top to bottom. Shows all the errors from top to bottom. Yes, it shows, compiler shows all the errors from top to bottom, right? Yes, main difference. Main difference between interpreter and compiler, exe file. Exe file is the main difference between interpreter and compiler. Yes, interpreter, yes, it does not generate exe file. Interpreter does not generate, does not generate, generate exe file. So interpreter, it does not generate exe file. Interpreter, it does not generate exe file. Compiler, it generates exe file. Generates, it generates exe file. Generates exe file. Okay, exe file, it generates exe file. It generates exe file, right? So next difference here, see, in case of interpreter, that code executing directly, source code. Yes, so this is your source code, program source code. That English language code, this is called a source code. It's a source code, source of Python program. Script, right? Source, that code executing directly. Source code executing directly here. Okay, so it will execute, see this, check it here. Here, only one file. Only source code file. Here don't have exe file. Don't have exe file. So only one file, source code file, right? Yeah, that source code file directly executes. Okay, interpreter, it executes source code exe. Sorry, it executes source code directly. It executes source code directly. It executes source code directly. See, when come to compiler, generating exe file, right? That means it executes exe file. It executes exe file. It executes exe file. It executes exe file. Okay, so interpreter executes source code directly. Yes, whereas compiler executes exe file. So compiler executes exe file at exe file. So next difference. Yes, interpreter based languages. Okay, these languages, interpreter based language, these languages are called as scripting language. Are called as scripting language. Scripting language, right? Scripting languages. They are called as scripting language. Okay, compiler based. Compiler based, these are called as programming language. Compiler based programming language. The programming language. So compiler based is a programming language. Okay. Yes. So interpreter based languages. So these languages are called as scripting languages. Compiler. Yeah, these are programming languages. Compiler based, these are programming languages. Programming language, right? Yes, interpreter based language examples. Examples of interpreter based language. Best example, Python, right? Just now discussed. Python is a interpreter based language. Next, HTML, yes, is a interpreter based language. Okay, JavaScript is also interpreter based language. Next, PHP scripting, interpreter based language. Perl scripting, interpreter based language. Linux, shell, shell scripting, right? Linux shell scripting. So these are interpreter based language. Okay, right? Interpreter based language. Python. Python has its own interpreter. Python interpreter, right? See, HTML, JavaScript. So these two are interpreter based. See, JavaScript is not a Java. JavaScript different, Java different. JavaScript working at the client side, Java at the server side. JavaScript client side, Java server side. Next here HTML and JavaScript. Yes, these executes in the browser environment. HTML and JavaScript, these are browser understandable languages. So these are browser understandable language. So browser is an interpreter. For HTML, JavaScript, for these two things, browser is an interpreter for the HTML and JavaScript. PHP is having its own interpreter. Perl is having its own interpreter. Linux shell is an interpreter. Okay, so HTML and Java. So these two are interpreters here. So for this browser is an interpreter here. So for these two things, browser is an interpreter. So these are interpreter-based languages. Interpreter-based language. Yes, compiler-based. Yes, examples. This compiler-based. Just now discussed about C and C++, right? C and C++, .NET, C#. So these are compiler-based. Okay, so these three are compiler-based. So these three compiler-based. Next, these are what here interpreter-based. Okay, right? Finally, some conclusion. See, interpreter-based language don't have exe files. Okay, see, HTML coding, .html file, no exe file. JavaScript, .js, no, yes, no exe file. PHP extension .php, no exe file. Perl extension .perl, yes, shell extension .sh. So all of this is no exe files. Here don't have any exe file. So these cases exe file. So finally conclusion, yes, interpreter based language don't have exe file. 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 Yes, in case of compiler, here finally generates exe file. Okay, always it's exe file. Okay, so finally generating exe file. Finally, yes, generates exe file. Yes, and executes, right? And executes. So this is difference between yes interpreter and compiler. I hope you understand, guys. So difference between interpreter and compiler, all these points. Interpreter and compiler, these are differences. Yes, now doubt. Okay, yes, maybe some doubt here. See, this trainer, Mr. M.N. Rao, yes, explaining all about all many things, right? Okay, so okay, fine, class is fine, everything explained, okay, but where is Java? Okay, but he's not talking about Java. He's talking about various things and many things, right? But not talking about Java. That is question, right? 100% getting doubt, right? Okay. Now Java. Yes, what is Java? Interpreter based, compiler based. That is question. Java. Yes, question is here. Is Java? Okay. Is Java? Yes, interpreter based or compiler based? That is question. Great. Yes, is Java interpreter based or compiler based? So this is question. Yes. Yes, anyone have the idea? Java, compiler based, interpreter based. Anyone?
Both interpreter as well as compiler.
Compiler base.
Compiler.
Samay is saying that compiler based. Somi Yadav saying that compiler based.
Yes.
Interpreter as well as compiler.
Samay is saying what?
Both interpreter as well as
Both
compiler.
interpreter as well as compiler. And next, Somi Yadav saying that compiler. And next,
Compiler based.
Vani compiler based. And next, can you guess it? Of course, I'll explain. Okay, yeah. Let me explain. So first of all, let me about how Java is working. Practical example I'll tell you. Then you decide it here. Practically one example I'll explain, then you decide. Okay. See, except Java, in other languages, what happens here? Except Java, other languages, maybe C language, C++, Python, HTML. In other languages, what happens here? Except Java in other languages. So first of all, source code, yes, simply converts into binary format. Binary format. Okay, source code. Yeah, that's C program source code, right? The source code. So this is a source code. The source code directly converts into binary formats. Source code converts into binary formats. Yeah, that binary code given to processor, right? So processor taking that code and generating output. So this is happening in other languages except Java. In other languages, source code converting into binary format, that binary format given to processor, generating output, right? This is what is happening with other languages. Yes, let us come to Java. Let me explain Java. Java. What happens in Java? Okay. Yes, in Java, source code. So first of all, source code convert into byte code. Source code converts into byte code. That byte code converts into binary code. Binary code. That binary code given to processor. So processor taking that binary code and executing. That's it. So what is happening here? There are two steps, right? Yes, here other language only one step. Source code to byte code only one step. But in Java, yes, two steps. First step, source code to byte code. Yeah, I'll explain. I'll show you practically. Source code to byte code. This part by the Java compiler. This part by the Java compiler. This part by the Java compiler. Next, byte code to binary code. Java byte code is the intermediate code. Some intermediate code was introduced. Reason for this intermediate code to make it as independent platform. Yes, byte code was introduced. Byte code was introduced to make the Java as independent platform. Yeah, that independent platform we'll discuss next. So next session I'll explain about independent platform. Okay. So next byte code to binary code. So next second part, byte code to binary code with Java interpreter. Yes, Java interpreter. Java interpreter. Yes, Java interpreter, right? Let me show that. Let us see practically. Okay. Suppose D drive, so test folder. Yes, it's the empty folder. Test folder, empty folder. Okay. Just I'm writing simple Java program using Notepad. Okay. Of course, our classes using Eclipse. In daily classes using Eclipse only. Using Eclipse developing Java program. Now here today, very simple Java program. Okay. Just I wanted to explain about Java depending on compiler interpreter. That's it. Not actual Java program. Actual Java program, yes, maybe tomorrow or day after tomorrow introducing. Java programming introducing from tomorrow. Yes. So D drive test, right? D drive test. CMD command prompt. Yes. So yes, we should go to D drive. D drive, right? So D colon that will take to D drive. CLS, clear skin. So D here. So D drive test folder, D drive test folder. See D drive test directory, folder directory, both are same. Already we have discussed it. Okay. Yes, now we should go to test directory. How can you go to test directory? CD, change of directory, CD command, CD test, change of directory, CD test, right? Changed, CLS. Now DR, right? Zero files, no files. See the test folder. This folder is empty. This folder is empty. This folder is empty. Zero files, right? Zero files. Now writing Java program using Notepad. Yes, Notepad, test.java. Notepad, test.java. Yes. Do you want to create new file? Yes. Right? Yes, public class test. Yes, class starting, ending. Right? Yes, next public static void. Yes, main string array of args. Array of args. Yes, main method starting, ending, right? Ending. Okay. Yes, in this system dot, yes, out dot println, yes, hello world. Simple program, hello world. Yes, hello world, right? Hello world. Save. Save, control yes, save and close. Next, go to command prompt, check it here, dir. Yes, dir. test.java. So this is source code. Test.java is a source file. See, this is Java source program. So this is source code. It's a source code, right? Source code. Now the source code compiling. So Java sim is Java compiler. Java sim is Java compiler, right? Yes, compiled, no error, no error. Now check it here. If no error, generated dot class file. See, dot Java is a source code. Dot class is a byte code. Dot Java source. Dot class, it's a byte code. It's a byte code. Okay, right? Now what is happening here? So what is happening? Yes. So what is happening here? See this. So first of all, tested.java. Yeah, this is source code, right? Yes, it's a source code. Yeah, the source code given to Java compiler, Java C, Java compiler, right? Source code file given to Java compiler. Java compiler checking whole code from top to bottom. If no errors, generating dot class file, tested dot class file. Here dot class file. This is byte code file. So this is byte code. It's a byte code, right? Byte code file generated. Okay. So this step completed. That compiler step completed. Compiler Java C checking all the errors. If no errors, generated dot class means byte code file generated. So compiler task is done. Java compiler task is done. Now we should run it. Java test. Java test dot test. Hello world, right? Yes, hello world. So what is first step here? See this. So Java C test dot Java first step compilation. If no errors, okay, no errors, generated dot class file. So what is next step? Okay, execution. Java test, right? Hello words. So you get Java C means is Java compiler. Here Java means what? It's interpreter. Java means it's interpreter. Okay. Java C means it's a compiler. So this part errors taken by the compiler. If no errors, generating dot class file. The dot class file taken by interpreter. So interpreter taking dot class file and converting. Dot class means byte code. That converting byte code to binary code, line by line converting, then executing. Yes, here is the interpreter. Interpreter checks, yes, checks and executes code line by line. Okay, line by line execution here. So this one executes line by line. Okay, so dot class file contains some byte code. So first line converting to binary format, then executes. Next line converting to binary format, then executes. Next line conversion to binary format, then executes, right? So that binary format will not store anywhere. That binary format will not store anywhere. Directly execution. Dot class file byte code executed directly. So byte code converts into binary code, then executes. Next line converts into binary code, then executes. That's it. So it won't generate an exe file. No exe file. No exe file. Okay. So you can know second part. So dot class file byte code to, yeah, this is by Java. So byte code file taken by Java interpreter. Java interpreter. Yeah, this topic I'll explain with JVM once again. Yes, JVM, that interpreter, Java interpreter. Java compile is okay. Yes. So about Java interpreter we'll discuss. Yes, again I'll explain. With JVM I'll explain here. Yes. So what happens here? So test.java source code taken by Java compiler. Yes, no errors. Generated dot class. Source code to byte code by the Java compiler. Now this byte code taken by Java interpreter. Okay, right? Now converting into binary codes. Binary codes line by line. Converting into binary code, that binary code given to processor. So binary codes given to processor. So processor taking that binary code, simply generating output. That's it. Okay, right? Yes. So here, so what is happening here? Source code to byte code by the Java compiler. Next, byte code to binary code by Java interpreter. That's it. So what is happening here? Java. Yes, Java. Yes, errors. Errors checking. Java errors checking by the compiler. Errors checking by the compiler, right? Compiler. Suppose if no errors, generates dot class file. If no errors, generates dot class file. Generates dot class file, right? After generating dot class file, yes, the dot class file executing by interpreter. Yes, program execution. Dot class file, program execution by the interpreter. Execution, yes, execution by the interpreter. by the interpreter, right? Execution by the interpreter. Okay. So Java, yes. Error seeking by the compiler, program execution by the interpreter. That means both are involving. Okay, compiler as well as interpreter. In Java, compiler, interpreter. So error seeking by the compiler, but runtime execution by the interpreter. Runtime execution by the interpreter, right? So now tell me, conclusion. What is Java? Yes, is it compiler based, interpreter based? What you understand from this? Finally, tell me.
Sir,
Java,
both compiler as well as interpreter.
Yeah, both
compiler,
compiler and yeah.
right? So first step compiler, next step interpreter. So both are involving. So Java depends on both compiler as well as interpreter. So Java depends on, yes, both compiler as well as interpreter. Yes, even latest version also same. Okay, someone saying that latest version, no compiler. Yes, I'm missing. No, your statement is wrong. Okay, yes. So Java depends on, yes, Java 17 version. This is here compiler first, interpreter, compile interpreter. Yes, somebody wrong. Okay, somebody wrong statement there. Okay, fine. Okay, right. Yes, so Java depends on both the compiler as well as interpreter. Java depends on both the compiler as well as interpreter. That's it, right? Yes, now question is here. Can we create exe file in Java? Anyone, can you answer? Yeah, just already discussed, right? Yes, tell me. Can we create exe file in Java? Just now the steps complete, right?
We
Yes,
can create by file handling.
So question is, can we create exe file in Java? See, in this process, have we observed any exe file? No. No exe file. So in this process, .java is there, .class is there. .java converting to .class. That .class kind of bytecode, that bytecode converting into binary code line by line. So line by line, right? Line by line converting, then executing. So that result is not showing anywhere. Means no exe file. So can we create exe file in Java? No. Most important question enter is here. Okay. So can we create exe file in Java? No. So why exe file concept removed from Java? 1 second. Just a minute. Let me have some water. So why exe file is concept eliminated from Java? See, exe file is concept removed from Java. Removed from Java, yes, to make it as independent of file. To make it as independent of platform, independent. Yes, independent of platform. Sorry. Independent of platform. Yes, this independent of platform tomorrow we are going to discuss. Yes, how Java, yes, tomorrow topic is about independent of platform. How Java made us independent of platform. Yes, no doubt tomorrow wonderful session I'll explain. Okay. Tomorrow session you will not see anywhere. No doubts. After, yes, after listening tomorrow class, yes, definitely, yes, you see that it's a wonderful session. Okay. Yes. So tomorrow topic is about independent of platform. Tomorrow I'll explain. Okay. So exe file concept removed from Java to make it as independent of platform. See, right? Yes, 1 second. So one point we have discussed. Interpreter based language don't have exe file, right? You program executing by the interpreter don't have exe file. See, in Java program execution by interpreter, right? Java runtime is interpreter based, not compiler. Java runtime is interpreter based. Since Java is runtime is interpreter based, no exe file. Java is runtime is interpreter based. Okay. Yes, since Java runtime. So runtime. So runtime is interpreter based. Java runtime is an interpreter based. So interpreter based, right? Since Java is interpreter based, don't have exe file concept. Don't have exe file. Don't have exe file, right? See, in Java, everything is dot class file. Okay, so everything is a dot class file. So everything is a dot class file. So finally generating a dot class file. So everything is a dot class file. Everything, yes, is a dot class file. Everything is a dot class file. Okay, so dot class file is not exe file. Dot class is different, exe file different. Okay, so dot class is not an exe file. Dot class file. Dot class file is not an exe file. Is not an exe file. Exe file different. Dot class file is different here. Okay, dot class is not an exe file. Okay, yes. So exe file dot class for tomorrow topic. Yes, tomorrow topic independent of platform. That time, yes, I will explain about what. Yes, what is exactly exe file? What is exactly dot class file? Tomorrow session I'll explain. So dot class file is not an exe file. See, exe file is a binary code file, right? Exe file is a binary code file. Exe file is a binary code file. Exe file is a binary code file. Okay, binary code file, and it's a system understandable language. Yes, processor can understand exe file directly here. Processor can understand exe file and execute, right? Yes, exe file is a binary code file, and it's a yes system. It's a system understandable. Yes, system understandable language. System understandable language. Yes, exe file is a binary code file, and it's a system understandable language. So when come to dot class file, see dot class file is a bytecode file. It's a bytecode file. So dot class file is a bytecode file, bytecode file, bytecode file, and it's a JVM understandable language. It's a JVM understandable language. JVM, yes, understandable. JVM understandable language. JVM understandable language. Right? Next, one more thing here. exe file is a platform dependent or OS dependent. exe file is a yes, yes, OS dependent or platform dependent. Yes, platform dependent. exe file is a platform dependent. Okay, so platform dependent. So why platform dependent? Yes, tomorrow I'll explain that. Okay, exe file is a platform, yes, dependent. Reason tomorrow topic. So why exe file is platform dependent? Tomorrow I'll explain here. exe file is a platform dependent. Yes, whereas dot class file is a yes independent of platform. Dot class file yes is an independent of platform. Independent of platform. Yes, how Java made us independent of platform? Yes, most important features of Java. Yes, independent of platform portability. Independent of platform portability. So because of independent of platform and portability, Java got this much of popularity. Okay. So most of the clients preferring Java. Reason independent of platform and portability. So what is independent of platform and what is portable? The topic tomorrow we'll discuss. Tomorrow we'll discuss definitely. Independent of platform portability. Yes. So that time I'll explain about exe file, dot class file differences. Okay. So definitely this is a wonderful session tomorrow. Okay. Tomorrow I'll explain a wonderful session. Just attend that. Okay. 1 second. Yeah. Today's session, documentation. This document for you guys only. Yes, I'll share with you. Yes. So today I'll take the yes all your email IDs from the online team who have paid. For them, I'll give the drive access. After finishing class, I'll give the drive access. Yes. So tomorrow it's a paid link. So as per their information, online team information, tomorrow it will be paid link. Okay. Yes. So today topic 2. Interpreter and compiler. Interpreter and compiler, the differences, all that points, what are the points explained here, prepared here. Simple, this is my documentation, right? Same as this, you can see this document I'll share with you. This is for you only. Today I'll create a drive for the recordings. So whatever discussed, I think 4 classes. For all the 4 classes recordings, I'll upload to drive. I'll give the drive access. Today night I'll give the drive access. Okay, fine. Drive access. So I will put into drive this one. Okay, right? Yes, see about Java. Today up depends on both compiler as well as interpreter. Yes, in Java errors taken by the compiler. Yes, if no errors, generates dot class file. Dot class file is a bytecode file. See, Java runtime by the interpreter. See, step by step. Source code to byte code to binary code, processor then output, right? Source code to byte code by Java compiler, byte code to binary code by Java interpreter. See, all same. So what are things expand? Same thing you can see in document here. Same as is, even single line is not missing. Okay, as is you can see. See, these documents never matching with any other documents in the different websites. Their document different, our document different. This document is completely my experience. Okay. Yes, this document completely my experience here. Okay. Yes. Right. Yes. 1 second. Hello. Hello.
Yes, sir.
Sir, 5 minutes call చేస్తాను క్లాస్ లో ఉన్నాను. Yeah. Yeah. So Java runtime is an interpreter based. See, any language runtime is interpreter based, no exe file. Since Java runtime is interpreter based, no exe file concept in Java here. Okay. So can we create exe file in Java? No. There is no concept of exe file in Java. In Java, everything is a dot class file. Dot class file is not an exe file. Okay, right? Yes, exe file is a binary code file and it's a processor understandable language. Dot class file is a byte code file and it is JVM understandable language. Okay, exe file is a OS dependent. Dot class file is independent of OS. Okay, yes, exe file dot class file difference. This is tomorrow topic. So tomorrow, excellent topic. Yes. Tomorrow we'll discuss about this thing here. exe file dot class file. How Java made us independent of platform. That features tomorrow we'll discuss. Yeah, that's all for today. Any doubts, guys? Any doubts? Any doubts?
Sir.
Just wait. Please don't leave. Just wait.
We understood all you have taught.
Yeah, wait for a minute.